Dear students, in this class, we are going to see the concept of directional cosines. And this concept is very much useful to write the wave equation in any arbitrary direction. And there are two types of incidences of a wave, normal incidence as well as oblique incidence. So if you want to write a wave equation in the oblique direction, definitely you have to take the help of this directional cosines. See, if you take, as usual, this x-axis, y-axis and z-axis, and this is x-axis, y-axis and z-axis. If the wave is propagating in x direction, you know how to write a wave. That is nothing but ex naught into e to the power of minus j beta x. That means the wave is propagating in x direction. If the wave is propagating in y direction, then you can write down here ey naught into e to the power of minus j beta y. Similarly, if the wave is propagating in z direction, then you can say Ez naught into e to the power of minus j beta z. But remember friends, the wave may not come only in three directions. Wave only x direction lonu, y direction lonu, z direction lonu raadu. Wave can come in any direction. For example, suppose మీరు ఎవరికైనా కాల్ చేస్తున్నారు అనుకోండి, and if you are receiving a call from somebody, then the wave can come in any direction. అంతేగాని it may not come only x direction లో, y direction and z direction లోనే రాదు. The wave can come in any arbitrary direction. Other than these three, you are going to expect the wave direction also. So if you want to write this wave equation for any arbitrary direction, let us say this is the arbitrary direction. You may not write this wave equation just by using the simple methods here. వీటికి రాసేటట్టుగా ఈ ఆర్బిటరీ డైరెక్షన్కి మనం రాయలేం. సో ఇఫ్ యూ వాంట్ టు రైట్ డౌన్ ద ఈక్వేషన్ ఇన్ దిస్ ఆర్బిటరీ డైరెక్షన్, దట్ మీన్స్ దిస్ డైరెక్షన్, then you have to use the concept of your direction cosines. Practically speaking, suppose for example, if you are taking this is a conducting medium, or otherwise it is a plate of a conductor. Whenever the wave is coming and hitting at an angle of 90 degrees, it is called normal incidence. Normal ga vastundi kabatti you can write down. Suppose if it is in x direction, you can say this is some ex naught into e to the power of minus j beta x అని మీరు రాస్తారు. But always practically the wave can come in arbitrary direction like this. ఇది x direction కాదు, y direction కాదు, z direction కాదు, arbitrary direction. So to write this wave equation for this arbitrary direction, then definitely you have to use your concept of direction cosines. So now let us see this figure. In this figure, what I am assuming is the wave is propagating in the arbitrary direction. Yes అనే arbitrary direction లో wave వెళ్తుంది ఇలాగా. And this ff is nothing but a constant phase. It is nothing but a constant phase. See, x, y, z లో x is equal to a constant, x is equal to a constant అనేది it is nothing but a equation of a phase from the concept of your uniform plane wave. Uniform plane wave అంటే ఏమిటి? It is having equiphases. So in x direction I am assuming that x is equal to a is a constant phase of a UPW. Now this ff is nothing but a plane. It is nothing but a plane which is normal to my assumed direction. Arbitrary direction ki, this arbitrary direction is nothing but s, and I am assuming here n is nothing but a unit vector in this arbitrary direction. So if I want to write down the equation in this arbitrary direction, I can take here n dot r is equal to constant. N dot r is equal to constant. So here, what is this n dot r? What is this n dot? N dot అంటే ఏమిటి? It is a unit vector or otherwise unit normal to this plane. అంచేత కొన్ని సందర్భాల్లో దీన్ని వేవ్ నార్మల్ అని కూడా పిలుస్తారు. దిస్ ఈజ్ నథింగ్ బట్ ఏ ఫేజ్, ఈక్వి ఫేజ్. ఈక్వి ఫేజ్ కి అట్ an angle of 90 degrees లో ఉంటుంది. దట్ ఈస్ కాల్డ్ వేవ్ నార్మల్ అని కూడా పిలుస్తారు. అండ్ ఆర్ ఈజ్ నథింగ్ బట్ ఏ రేడియస్ వెక్టార్ ఫ్రమ్ O to P, the point of consideration. So this n dot r will give you n dot r dot product ఏం చేస్తుంది, it gives the projection of this n dot r in this unit vector direction. So what is this n bar and what is this r bar? R is nothing but a radius vector whose components are x, y and z. So r is nothing but the resultant of the components in x, y, z directions, and n bar is nothing but having its component in terms of cos. So I can say n dot r bar is equal to, I can say that this is x cos A plus y cos B plus z cos C. And here remember this x and y and z, these are the components of, these are nothing but the components of r in x, y, z directions. These are the components of r. But whereas this cos A, cos B, cos C are nothing but the components of your unit vector in x, y and z directions. But remember, what is A, B, C? What is this A and B and C? And this A, B, C are nothing but the angles with respect to x-axis, y-axis and z-axis. చూడండి, A is an angle with x-axis to the unit vector, because I am taking this arbitrary direction. I am writing the wave equation for this arbitrary direction. మీరు అనుకున్న డైరెక్షన్ మీ 3 సెట్ ఆఫ్ యాక్సెస్ తోటి ఎంత యాంగిల్స్లో ఉన్నాయి, x యాక్సిస్తో A, y యాక్సిస్తో B అండ్ z యాక్సిస్తో C. సో ఇఫ్ యూ నో ద యాంగిల్స్ ఆఫ్ A, B అండ్ C, then you can calculate cos A, cos B, cos C. And x, y, z are nothing but the components of your R in x axis, y axis and z axis. So that's why n dot r is equal to x cos A plus y cos B plus z cos C. And this cos A, cos B, cos C are called as the direction cosines అని కూడా పిలుస్తారు. Direction cosines. Now once you know this n dot r is going to decide the direction. Actually, if the wave is coming in x direction, e to the power of minus j beta x, you know this. If the wave is in y direction, e to the power of minus j beta y. If the wave is in z direction, e to the power of minus j beta z. కానీ నేను తీసుకున్న వేవ్ ఆర్బిటరీ డైరెక్షన్, it is not x direction, it is not y direction, it is not z direction. It is an arbitrary direction. This direction will be given by this n dot r. What is this n dot r? X cos A plus y cos B plus z cos C. A, B, C are nothing but the angles with respect to x axis, y axis and z axis. So based on this concept, already this one bit is given in your gate examination also. We can discuss it later. Now, for writing this wave equation, I can say E of r is equal to, that means in this direction, electric field intensity at a distance r is equal to some magnitude into e to the power of minus j beta. Now it is not x, it is not y, it is not z, it is the resultant of all this. That's why it is nothing but n dot r. So minus j beta into n dot r. So what is n dot r? N dot r is nothing but, you can say that x cos A plus y cos B plus z cos C, y cos B plus z cos C. So I hope you understood the way of writing the wave equation in any arbitrary direction. So if you want to write the wave equation in this s direction, which is arbitrary here, just you have to know the values of A, B, C. Angle with x axis, angle with y axis, angle with z axis. X, y, z are nothing but the components of this radius vector. Then definitely E of r is equal to some magnitude into e to the power of minus j beta into n dot r. So whenever he is asking you to write the wave equation in an arbitrary direction, try to observe what are the values of A, B, C. Angle with x axis, angle with y axis, angle with z axis. Just substitute in this equation n dot r. use this n dot r in this expression, you are going to get a wave equation. Okay, right. Now, sometimes this E naught is having both real part as well as imaginary part also. So let us discuss this. Okay, just now we have seen the way of writing the wave equation in arbitrary direction. How it is? E of r is equal to some magnitude E naught into e to the power of minus j beta n dot r. So what is this n dot r? N dot r is equal to x cos a plus y cos b plus z cos c. Z cos c. Now, the final equation is E of r is equal to E naught into e to the power of minus j beta into x cos a plus y cos b plus z cos c. So, if you know the angles with respect to x axis, y axis and z axis, and a, b, c కనుక మీకు తెలిస్తే, you can write this equation here. But this E naught is not only real, it may be imaginary also. That's why your E naught will be equal to some real part plus as well as some imaginary part also. So, if you substitute here and if you write a wave equation, that means which is a function of distance and time, and you have to incorporate the time variation here as usual. Therefore, I can write here E dash of r comma t is equal to E dash of r comma t is equal to, take the real part of it, E naught into e to the power of minus j beta n dot r after multiplying with this e power j omega t. మీకు తెలుసు, if you want the time variation, first of all you have to multiply with this e power j omega t and take the real part of it. But this E naught is not only a real number, it is having both real as well as imaginary number. Okay, so that's why E dash of r comma t is equal to, and take the real part of it. What is this E naught? E naught means real part plus j times imaginary part into e to the power of minus j into beta of n dot r minus omega t. So this is equal to, take the real part of it, er plus j times ei into cos of beta n dot r minus omega t minus j into sin of beta n dot r minus omega t. This is. Now take the real part of it. Real part means the first term is nothing but the real part. Therefore, E cap of r comma t is equal to, and you can say er into cos of beta n dot r minus omega t, and if you take the multiplication of this and this, it is imaginary, and this is also imaginary. The last one is nothing but the real. J into j means j square is minus 1, so that plus, and this is ei sin of beta of n dot r minus omega t. So this is the way of writing this equation. So E cap of r comma t is equal to, it is the final equation. Nothing is done. Already మనకు తెలిసిందే. Time varying form రాయాలి అంటే you have to multiply with e power j omega t and take the real part of it, right? So this is the way of writing the wave equation in any arbitrary direction. So finally I would like to tell you, ఏదైనా ఒక ఆర్బిటరీ డైరెక్షన్లో కనుక వేవ్ ఈక్వేషన్ రాయాలి అంటే the information required is ABC. ABC means angle with x-axis, angle with y-axis, angle with z-axis. Then where we are using this concept, already we have discussed about this reflection of electromagnetic waves at normal incidence. Normal incidence అంటే యాజ్ యూజువల్గా రాసేస్తాం ఈక్వేషన్స్. But whenever you want to discuss about the oblique incidence, that means the wave can come in any direction. Then if you want to write a wave equation, then definitely you have to use the concept of directional cosines. I hope you understood the application of it also. So let us verify this concept with a small problem.